Hello everyone. The next topic is electric flux. What is the definition of electric flux? The number of field lines passing through any imaginary surface is called electric flux. You can see in this. So here I have taken one surface. So here the electric field is strong. So why the electric field is strong? Because the density of the electric field line is higher. So you can choose any of the surface. The number of lines passing through this surface, it is called electric flux. So here you can see the greater number of electric lines are passing through this surface. Why? Because greater flux passing through this surface. So here you can see, we can also count 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many number of lines passing through this? By theoretically we can say, but practically it is not impossible to count the field lines. So what is the definition of electric flux? The number of lines passing through the imaginary surface is called electric flux. So now you can see in this area, the surface area is small. So now the number of field lines is less. So here compared to this and this is large and this is small. So in this smaller area, the field lines passing through are less. Here the field lines are large. Why? Because the surface is more. Here the surface is less. So this is electric flux. Next is the mathematical expression for electric flux. So we know that the number of field lines passing through the surface, then E is the electric field and N is the number of field lines. So and this is the area vector, then it makes an angle theta. This is a surface. So magnitude of S is equal to S. Then S cap is equal to N vector, N cap or minus N cap. So you can see now, so the electric flux we can denote it by phi is equal to number of field lines E, electric field lines S cos theta. So here we can also write it as phi is equal to E dot S. So where E is the uniform electric field and S is the area vector. So if electric field is uniform, if the electric field lines is uniform, the electric field is parallel. If the electric field lines are non-uniform, we know that already, the electric field is non-parallel. Next, if the electric field is non-uniform, you can see phi is equal to integration of E dot ds. So where ds is equal to small area element. So here we can choose smaller area element. Then so this, it is a scalar quantity and also we can denote it by what is the electric field? SI unit Newton Coulomb per and S is meter per square. So what is the SI unit of electric flux? Newton Coulomb per meter square. Next, here is one question. So if an electric field is given to be 5 I cap plus 4 j cap plus 6 k cap. So this is a vector they have given. So what is the electric flux through a surface of an area vector? So we need to find out for this vector. So what you will do? So you can take the formula of electric flux, phi is equal to E dot S. So no need to write cos theta here because it is a dot product. Then phi is equal to, they have given E, you can take that phi I cap plus 4 j cap plus 6 k cap dot I cap plus 2j cap plus 3k cap. So now we know that you can just multiply because dot product is there. Phi into 1 plus 4 into 2 plus 6 into 3. So you can multiply I cap plus jj cap plus kk cap. Then dot product. Then 5 into 1 5 plus 4 2s are 8 plus 6 3s are 18. So if you add, you will get 31. So what is the electric flux? 31 Newton Coulomb per meter square. So this is one of the example. So you can take, this is also one of the example for phi is equal to E dot ds cos theta. So this is here they have given the theta here. Charge q is placed at the center of the sphere of a radius r. Then find the flux of the electric field. Okay, the surface of a sphere due to the enclosed charge. So we know the formula E dot ds. Then theta is 0 degree. Here we couldn't take the theta. So then we know the formula, that is E dot ds, the dot represents cos theta. So here theta is 0 degree. Then you can take E outside and integration of ds. So we know the formula of E, electric field, we know the formula Q by R square. So that is KQ by R square into, what is the area of the sphere? 4 pi R square. So if it is 4 pi R square, then we will get, so R square get cancelled, then the remaining 4 pi KQ. So phi is equal to 4 pi KQ. So this is the electric flux. And the next topic is continuous charge distribution. So what is the definition of continuous charge distribution? You can take any of the system, so in which the charge is uniformly distributed throughout the system. So you can take any of the example for straight wire, then you can take a charge sheet or a sphere. So the charges can continuously distributed through the system. That is called uniformly charged, continuously charged distribution. So now in this space you can see infinite number of charges can distributed, so in the closed pack, and have a minus space between them. So because this is a solid, we know that. So then the types of continuous charge distribution. There are three types of continuous charge distribution. So one is linear charge distribution, second one is surface charge distribution, third one is volume charge distribution. So now you can take, first one is linear charge distribution. So now here I have taken linear charge distribution. Here I have taken a straight wire. So the length is capital letter L. So here I have to choose particular area. So here in this length I have taken only this much area. So why? Because if you are going to take continuous charge distribution, we cannot find the charge. So that's why here we have to take first one particular area you can choose, then I can name it as dq. Then dl. Okay. So now what is the linear charge distribution? So we know that already the linear charge density is lambda is equal to dq by dl. So this is the formula for linear charge distribution. Then dq is equal to cross multiplication lambda into dl. Then for uniform charge distribution we have to take integrals. So from 0 to q, dq is equal to integral 0 to L, then lambda into dl. So what is the integration of dq? Q, that is equal to, what is the integration of lambda? Lambda you can write as it is because it is a constant. Then what is the integration of dl? L. So now we got lambda is equal to q divided by L. So now we can say q is a charge uniformly distributed over the line. And what is L? So the length of the rod. So what is the formula for linear charge distribution? Lambda is equal to q by L. Where what is the unit of linear charge distribution? Lambda is equal to q by L. Then q is a coulomb and L is in meter. So coulomb per meter. That is the SI unit of linear charge distribution. Next, surface charge distribution. See here I have taken a surface, any one of the surface you can take. So here I have taken this surface. So we can't see here the charges are continuously and uniformly distributed throughout this area. So we can't count the charge from this full area. So for that reason we have to choose one particular area. So then that is sigma is equal to dq by this area. Okay. So for uniform distribution, here we have chosen sigma is equal to q by a. Then where q is equal to charge uniformly distributed over the surface and a is the area of the plate. So this is a surface charge distribution. So next tell me what is the SI unit of surface charge distribution. Here area is there, so that's why coulomb per meter square. So coulomb is for charge and area for meter square. So what is the SI unit of surface charge distribution? Coulomb per meter square. Next, the last one is volume charge distribution. So here we have chosen sphere. See in this uniformly charged continuous charge distribution. So here also we have to choose, you can see this volume of the sphere. So here we have taken, it is denoted by sigma, rho. Rho is equal to dq by dv. Then for uniform charge distribution, rho is equal to q by v. Then where Q is the charge uniformly distributed over the surface, then V is the volume of the sphere. Then what is the SI unit of volume charge distribution? So here Q is a coulomb and volume means that is meter cube. So the SI unit of volume charge distribution is coulomb per meter cube. So these are the types of continuous charge distribution. So here one example is there. So here a uniformly charged conducting sphere of 2 meter diameter has a surface charge density is 80 microcoulomb per meter square. Find the charge on the sphere. So here you can see they have given meter square. So meter square they have given. So on the radius, so here they have given the radius is 2 meter, means diameter they have given, 2 meter diameter they have given. So now if you find out the radius, you can divide it by 2. So that is 2 divided by 2 is 1 meter. So they have given the surface also. So what is the surface charge density? Sigma is equal to 80 microcoulomb per meter square. So we know the formula of surface charge density. Sigma is equal to dq by dA. So here we know the formula. Q is equal to sigma divided, Q is equal to sigma into area of the sphere. Then Q is equal to sigma into, what is the area of the sphere? We know that 4 pi r square. Then Q is equal to, what is the sigma? 80 micro. Micro means 10 power minus 6 into 4 into, what is pi? 3.14 into, what is the radius? 1 square. So then what is the charge? So you can multiply with this 80 into 4 into 3.14 and multiply with 10 power minus 6. So you will get 10 power minus 3 coulomb. So this how, that is how we can find the surface charge density. The next topic is electric dipole. What is, and here the learning objects are dipole moment, electric field of an electric dipole, dipole in a uniform external electric field. So our first topic is dipole moment. The definition of electric dipole is, so here we have taken two pairs of equal and opposite point charges, minus q plus q, and there is a small distance between the charges, that is called electric dipole. A pair of equal and opposite charges separated by a small distance, minus q plus q, and the small distance is from the midpoint, so A and A. So we will get 2A. So it is a electric dipole. It is a pair of equal and opposite charges separated by the small distance. Is called electric dipole. Next is dipole moment. What is the meaning of dipole moment? So here the dipole moment is a magnitude of charges and the product of charges and the distance.